Let's look at part 5 here on data tables. As you would have seen in the warm-up and the why as well as the target for today, we're really focusing on making sure you can make data tables that meet guidelines of what makes it a good data table. So you'll see today's lesson is going to go into 2 pages, so starting on page 5 and then 6, just because we needed more space to lay out these directions. But there's not that much for you to write, okay? The first question here is, what is a data table? You don't even really need to write anything there. I just want to make sure you understand data tables are not graphs. People always get graphs and data tables confused. This is a data table down here, okay? A graph would be like a line graph or a bar graph or a pie graph, okay? These are data tables. So what makes a good data table? First of all, it needs to be a table. You can't just list your data. It's not like you can just have a laundry list of 2 centimeters and 8 centimeters and so forth. It needs to actually go in a table. You want to have a layout that makes sense with rows and columns that are really labeled. And you want to make sure the units, this is something I'm going to try to really work on you this year with, you need to make sure the units go up in the titles, not in the individual numbers. You don't want to have each of the cells saying something like 2 centimeters, 3 centimeters, 4 centimeters. That just really takes up a lot of space. That makes it harder for someone to just quickly understand your data. So these steps are what we're going to kind of follow. You want to make a table containing columns for the independent variable, which is what you're controlling. The dependent variable, which is what happens that's out of your hand. So if you're controlling how much light a plant gets and then how much it grows, the amount of light would be what you're controlling, which is the independent, and then the dependent is how much it grew because of that light. So you are not making that plant grow. It's up to that plant to grow using photosynthesis and other things that you've learned in bio, and that's going to be your dependent variable for how much it grows. Make sure you label with your units, okay? Divide the column for the dependent variable if you have different trials to kind of put into play, and you'll see us do that too here when we practice. Under the independent variable column, which is generally on the far left, okay, that's what you're controlling, you want to list the different levels or treatments that you have. So for this example, the effect of age, the compost age on plant height, okay, so in terms of what you're using as your soil. So if the age of the compost is what you're controlling, how old that compost is you're using in months, 0 meaning it's not compost that you're using, it's just a control. 3 months and 6 months, that's what you're controlling. So this first column is going to be that different levels or treatments of what you're controlling, okay? And that's what I've put here. Levels of the independent variable go here. The independent variable is this one, okay? Now, generally, you want to go smallest to largest if you have numbers. Okay, you wouldn't start with 6 months. You'd start with 0 and we'll kind of work your way up. The title of data tables, when we look at that this year, it's the effect of the independent on the dependent. So for this one, the effect of compost age on plant height. You want to record everything in the locations without units. So we'll work on practicing when we put in the numbers here. Okay, so I've just written dependent variable goes here with the units. And then if you have any sort of average you're doing, you can kind of put that here. Sometimes we won't do that, but if you do have that, you can add that in as the last column. So let's look at this next one. So we're going to practice making a data table here, okay? Create a data table for following data. An experiment to determine the effect of plant nutrients on plant growth. So right there I'm thinking, I'm controlling the nutrients I'm giving, so that's independent. The plant growth, again, I can't control how much that plant ultimately grows, so that's dependent. John, okay, he's doing the testing. He set up 3 plants, exposing them all to the same conditions except for nutrients. That's telling you that he's not changing a bunch of things at once. He's just changing the nutrients. First plant was given Miracle-Gro. So that's the independent variable for that first plant, okay? Second was given Botanicare. That's another name of a nutrient, so that's an independent. Third was not given anything, okay? Now, he measured the height of the plant every 3 days for a total of 5 measurements each, okay? And then the first plant had heights of 1 centimeter, 3 centimeters, 7 centimeters, 8 centimeters, and 11 seconds are listed here. Third listed here, okay? So if we're following what we were just talking about, okay, we're trying to figure out the nutrients and how it affects the height on the different days, okay? So in terms of a name for this data table, it's always the effect of the independent on the dependent. So the effect of plant nutrients on plant growth, okay, would be kind of the name for this data table. Now, we're going to work on writing out a data table that makes sense. It's possible that your data table looks a little different than mine if you were just to start doing this on your own, and that's okay. But what we're working on is okay, what can we do to make a data table that makes sense to someone, okay, so they understand what's happening, right? if we look at this, we can set up in the first column our independent variable if we do it like that example I had there for you, okay? So our independent variable is going to be what we controlled. So the control doesn't have any nutrients, the Miracle-Gro, the Botanicare, okay? So I'm gonna just try to throw a table in here. Obviously, you'll be writing it by hand, okay? Now, we're gonna need some columns as well, okay? So right now I'm just gonna kind of pick them out. I'll change it as we need, okay? But I know that I need 4 rows, okay? Because I'm gonna put nutrient listed here. So control, which means none. Miracle-Gro. And then I've got Botanicare. Okay? So like that last example on the last page, I'm kind of writing my control there for nothing. And then Miracle-Gro and Botanicare. On this side here, okay, I have what the dependent variable is, so plant height, okay? Now, we did measure it every 3 days, okay, which we want to make sure that we put here. And then we're going to have to put the heights in there as well, okay? So I'm thinking, all right, I need to write, something about plant height, and then I need to write the days that I took the measurement, okay? So I'm going to try to divide this up a little bit more, but I'm thinking about, okay, so every 3 days for a total of 5 measurements each, okay? So day 3, 6, 9, 12, 15, okay? So I need to have 5 different columns here for the heights, okay? So I'm going to add in some, do it this way. I'll add in some columns because I think I need 2 more. And again, this is one of the things as you're writing data tables, you might change it a couple times. So I do want to have an extra row, okay? So I'm going to put a row above this, and you'll see why, okay? So what I'm going to do here is I'm going to merge these to make this say, all right, we're thinking about the height over different days, okay? So as I'm thinking about this, I'm going to merge these and say, all right, so I have plant height in centimeters, okay? Now I'm going to write day 3, day 6, day 9, day 12, and day 15, because I measured it every 3 days. So I'm trying to tell someone that I measured it every 3 days, and these are the heights that I got, okay? So what I'm going to do next, make that look nice there, is I'm working on, okay, what were these measurements at those days? So my control, which is the first plant had heights of, and the first plant was Miracle-Gro, okay, so I can list that one first if I want. First plant had heights of 1, 3, 7, 8, and 11, okay? Then it says the second plant was given Botanicare, and its heights were 2, 3, 6, 7, and 8. And then the control, which wasn't given anything as treatment, were 1, 2, 3, 5, and 6. So what can you see from the data? Well, the control grew the least at only 6 centimeters. Botanicare grew 2 more centimeters. The Miracle-Gro really took off and grew almost double the height of the control, okay? So what you can see here is with this data table is I put my independent along the left there in the first column. Along the top, I divided it up for my dependent variables. And then most importantly, notice I did not write 1 centimeter and then 2 centimeters. If you do that, it's going to be overwhelming. You've got all this extra stuff in your data table. I don't need centimeters listed there because I already have it right here after the description of what you're measuring so that they know it's in centimeters and you don't have to type it every time. First of all, you don't have to type it or write it, which is going to save you time. And second of all, when someone looks at your data table, it's just easier to understand quickly what's happening, okay? So that's one example of a data table. If you made yours look a little different, that's fine, as long as you followed those guidelines to kind of make it organized and laid out well, okay? I would like you to try it with this third one here, and then you're going to try a mastery check to see if you can make a data table that makes